Is up, winning team. Yo, I was acting a fool. You guys should see the way I be acting a fool right before I start recording. Holy Spirit, please be with us. I can't remember if I even invited him. I was too busy acting a fool. Okay. So today we're continuing in our book series. We're reading the Beyond the Veil, exploring the bubble theory and the fourth dimension. Guys, we're talking for who remembers like a year, as I was telling you guys for a while, I was like, eventually we're going to get to the dimensions. Eventually we're going to get to the dimensions. Eventually we're going to get to do you remember when I was saying that we're going to get to the dimensions of the universe? And we're here now. I'm so excited. This is like the best thing. So A Beginner's Journey into the High Dimensions and Modern Physics, Beyond the Veil, exploring the bubble theory and the fourth dimension by Jamil Chamberlain. We're in chapter 8 today, When Bubbles Interact. If you're new, this is the first video hearing, don't worry. We have a whole playlist in the description box down below. You can check out the intro. Why are we doing this? Why should you be here? Why are you even interested? We've got an intro video and all the videos of all the chapters of this book. So go and check that out. And we've also got the book linked. I bought it on Amazon. It was super cheap. It's really good. So I will, so go and check it out if you'd like. Either way, I'm going to be reading it, and let's get straight into chapter 8. So today we're doing When Bubbles Interact. And we previously in chapter 7 had really delved into bubbles in the fourth dimension and really getting our minds around this concept of the S energy field and the bubbles existing in them, in the fourth dimension. So let's just get straight. Let's just start reading. So chapter 8, When Bubbles Interact. Visualizing the fourth dimension. Understanding how bubbles exist and interact in the fourth dimension requires us to stretch our imagination. While we can't perceive the fourth spatial dimension directly, we can use analogies and models to conceptualize it. The Flatlander revisited. Recall the Flatlanders from earlier chapters. Beings living in a two-dimensional world. To them, a three-dimensional object passing through their planes appears as a series of changing shapes. Yes, I understand, right? Similarly, a four-dimensional object interacting with our dimensional world might manifest in ways we can't fully comprehend. Bubbles, the way I'm understanding that, and I don't know if I'm understanding this correctly, but the way I'm understanding that, when it says a series of changing shapes, it's as if the shadow example that I keep referring to, because it's the one that really made a lot of sense to me. When you look at your shadow, obviously the more you move, your shadow changes, looks like a series of changing shapes. Your shadow being two-dimensional, you being three-dimensional, you haven't changed. Your shadow has changed based on the context of it being seen in different ways, because you are moving. In the second dimension, looks like it's changing shape. That kind of thing, right? Bubbles as four-dimensional structures. In the bubble theory, bubbles extend into the fourth dimension. They aren't confined to our three-dimensional space, but have structure that includes the fourth spatial dimension. Unique S energy signatures. Each bubble's existence and properties are defined by its signature within the S energy field. Overlapping space. Okay, so let me just make sure that I just proper understood what we just said right here. They aren't confined to our three-dimensional space, but have a structure that includes the fourth. A unique S energy signatures. Each bubble's existence and properties are defined by its signature. Yeah, of course, that was what we're talking about. Okay. Overlapping spaces without interaction. So the stacked sheets analogy is where we're at now. Imagine a stack of transparent sheets of paper, each representing a different bubble. Though they occupy the same horizontal and vertical space, they remain separated because they are at different heights, analogous to positions in the fourth dimension. Independence. Each sheet has its own drawings, matter and energy, that don't interfere with those on other sheets. Fourth dimensions as separation. The height separating the sheets represents their unique positions in the fourth dimension, maintained by their S energy signatures. Cool. So I think that's pretty self-explanatory. Yeah, I think that's pretty self-explanatory. 3D shadows of 4D shapes. Just as a three-dimensional shape object casts a two-dimensional shadow, a four-dimensional bubble might cast a three-dimensional shadow in our world. So here we go. Partial perception. We might observe effects or phenomena resulting from higher dimensional structures without seeing them entirely. That's the thing that I really find so fascinating about this, because I'm just like, that opens the door to a lot of possibilities, because how many things could we be perceiving that are actually like essentially three-dimensional shadows of what's fourth dimensional? And is our existence itself just that? Because that's kind of like where my thinking goes. But we'll come to all of that, right? Because yeah. Unexplained phenomena. Certain anomalies or unexplained events could be glimpses of higher dimensional interactions. Maintaining bubbles' integrity. The role of the S energy signature. The S energy signature ensures that each bubble remains cohesive and distinct. Structural stability. It binds matter within the bubble, preventing it from dispersing or merging with other bubbles. Consistency of physical laws. The signature determines the bubble's physical properties and laws which could differ from those in other bubbles. Energy levels and stability. A bubble's energy level affects its stability in the fourth dimension. Sufficient energy, adequate S energy maintains the bubble's integrity. Energy fluctuations, loss or gain of energy could affect the bubble's stability or cause changes in its S energy signature. Sorry, I keep pausing because I haven't said this out loud, but I thought I would just say it to make this whole series more interesting. This whole theory in and of itself actually questions a lot of things that I was initially thinking about the fourth dimension, hence why I'm so fascinated by this. As in, like, I reckon if not for the way that I came across this book initially, I don't know that I would have ever necessarily considered this theory to the same extent. I probably would have never come across it, I feel. So praise Jesus. Interaction between bubbles. While bubbles generally remain separate due to their unique signatures, certain conditions might allow for interactions. Interlinking bubbles, signature alignment. If two bubbles' S energy signatures become similar, they may begin to interact. Overlap in the fourth dimension. This could lead to shared spaces or the transfer of energy and matter between bubbles. That is very, seriously interesting. Consequences of interaction. Anomalous events. Interactions might explain unexplained phenomena such as sudden appearances or disappearances of matter. Energy exchange. Transfer of S energy could impact the stability of the involved bubbles. Now, this is what is fascinating me about this, is because the thing that pops into my head immediately is one of the laws of thermodynamics, which is that energy cannot be created nor destroyed, but it can be transferred. So this is quite interesting. Because we thought about it internally, in an internal sense within the universe. This is like opening the door to, does that now something we're stretching outside the universe, like to the other universes, to the other bubbles, according to the bubble theory? This is what this has me thinking about right now. Real world parallels. Quantum tunneling. In quantum mechanics, particles can tunnel through barriers they shouldn't be able to cross based on classical physics. Analogy to bubble interaction. Just as particles can appear on the other side of a barrier, matter from another bubble might manifest in our bubble under specific conditions. Okay, so resonance in physics. When two systems share a resonant frequency, they can exchange energy efficiently. Bubbles aligning. If bubbles reach a resonant state due to matching S energy signatures, interaction becomes possible. Challenges in perception and detection. So we have sensory limitations, technological limitations, and then we go into another part, which I will not go into right now. So sensory limitations. Our senses are not equipped to perceive the fourth spatial dimension directly. Instrumental detection. We rely on instruments to detect phenomena beyond our natural capabilities, but detecting higher dimensional effects remains a significant challenge. Also, I would imagine that if you have to rely on instrumentation, you'd have to be able to understand what that instrumentation would have to do to be able to detect the phenomena in the first place. And so the next question becomes, how do people even come up with these instruments in the first place? To like, because like if you're saying that this instrument can detect certain phenomena or natural capabilities, detecting high dimensional effects, we have to understand enough in order to create those instruments in the first place. And so my question then becomes, how exactly do we do that? If that makes sense, how do we create those instruments? Interesting. Technological limitations. Current technology may not be sensitive enough to observe or measure interactions with higher dimensional bubbles. So future advances, as technology evolves, we might develop new methods to explore these dimensions. Do you know what just really randomly popped into my head as I thought about this? You guys know that I'm doing a whole series on you might not know if you watch, especially if you're watching this, because what I'm about to say is about to be a complete other side of thought to this, but you guys know I've been doing a whole series about like the ancient kingdom, the floods of Noah, what was going on, the Nephilim, the giants, what was there, but yada yada yada. Is it a myth and fable, or is it forgotten history, etc.? I would be very interested to know how that might tie into this. And you know how there's all this technology and things that people don't understand about things on the earth, and like who built the pyramids, this, that, and the other. I wonder if, as we are suggesting, or as has been suggested, these ancient civilizations would have had something to say about this stuff. Like maybe they had the technologies, the instrumentations to explain some of these phenomena. Maybe they knew these things. Maybe that's part of, who knows? You know, these are the thoughts. It's quite interesting. So embracing possibility, exploring bubbles in the fourth dimension encourages us to expand our horizons, consider realities beyond our immediate perception. Consider realities beyond our immediate perception, foster innovation, inspire new approaches in physics and technology, cultivate curiosity, keep an open mind about the mysteries of the universe. And I think that's the really important take-home message I want everybody to take away from this, even if some of this stuff maybe you don't care about, or, you know, even if you feel like some of it's going over your head. I highly recommend, you know, this is why I do say that I feel like I love having books that you need to reread. This is why I be rereading some of this stuff, by the way, guys, because you got to like wrap your head around it, and it's new thinking. You got to be open-minded as a scientist. Like, you got to be the kind of person that expands your horizons, just as it literally says here. Expand our horizons, right? You got to be open. Like, the one thing about scientists, and the reason why scientists are, quote, people be like, oh, scientists are so intelligent. Scientists are very open-minded people. And I was just thinking about how, you know, in a lab situation, like I remember that there'd be times like we'll be in the lab doing experiments, and to the average person, right, doing something 100 times, 200 times, 300 times is insanity, because that's the actual definition of insanity. It's doing the same thing over and over again and getting different results. And yet, as scientists, if you believe that there's a statistic that if you do this exact experiment 1 in 100 times, you're going to get a particular desired product or desired outcome, you will, as a scientist, do it 100 times, probably maybe 300 times, to give yourself a bit of leeway, because obviously statistics are not exact. It's just a probability, right? Because of the belief of that thing happening even once. A lot of science and the like reason why science pushes forward is not because people go, oh, we just trust everything exactly that we've heard. It's that we take into account everything that we've heard, and then we consider what we haven't considered and what other questions and things could be considered going forward. So even like when I did my own research, as I told you guys, at the end, the final section of the report was future work. So where do we go from here? This isn't the end point. Where do we go from here? What is what you've learned? How does that now take you to the next step? And that's what I think is so cool about science. Science, it's like a relay. It's like a relay race, and we're all scientists where in our time we get our chance to discover whatever we discover and push forth the understanding in the time that we're here, to then what comes next, and then what comes next, and then what comes next. And which is really, really cool. So be open-minded, be prepared to and this is why I even started to talk about, you know, to me, there's two sides of the same coin, right? Were the giants real? Is there a fourth dimension? Because open your mind until it's like the Schrodinger's cat thing about, you know, is it the cat dead or alive inside the box? Because we don't know if it's dead or alive. It could be dead or alive. Like, we as people, just because something isn't proven to be true, it also isn't proven to be not true. And that's the way that I look at things. You can tell, and with a lot of things, like, yes, something might not be proven to be true, but if you also can't prove to me that it's not true, then you can't tell me that me thinking that it's true or suggesting or researching that it's true is foolish, because you also can't prove that it's not true. Does that make sense? And so be aware of that, I would say, to anybody out there in the world interested in science. So I love about science. And our key takeaways from chapter 8. Bubbles in 4D. Bubbles exist as four-dimensional structures with unique S energy signatures. Coexistence without interaction. Bubbles occupy the same space but remain separate due to their unique signatures and positions in the fourth dimension. The analogies that we had used, the stacked sheets, if you remember, representing bubbles as layers that don't interact. Shadows of 4D objects, higher dimensional objects casting perceivable effects in lower dimensions, interlinking possibilities. Under certain conditions, bubbles might interact, leading to potential energy or matter exchange. Challenges in detection, sensory and technological limitations hinder our ability to perceive or measure higher dimensional phenomena. Speculative implications, consider how bubble interactions might explain certain phenomena, though these ideas remain theoretical. So, really interesting, you guys. I hope you're enjoying this. In our next episode, we'll be on chapter 9, Rethinking Gravity and the Forces. Oh, I can't wait for this, because gravity is one of those things I kind of touched on with you guys that I have some reservations about and things. So I'll be curious to see Rethinking Gravity and the Forces. I have thoughts about certain things, because there are also some things that don't make a complete sense to me. I can't believe we're this far into the book. Are you kidding me? The heck? The conclusion is page 95. We're on page 55. We're 40 pages away. This is so much fun. So yeah. Anyways, you guys, if you want to see more about this, like I said, go and check out the other videos. Check out the intro for the full explanation of why we're doing this. Full playlist is linked in the description box. Link to buy the book is in the description box. Check it out. Go and maybe just see to get more information if you would like. Other than that, you guys, I'll see you in the next video, because if life's a game, let's play to win. God bless you all. God loves you. I love you. And I'll see you in my next one.